Hi guys, I'm James Patrick Valeriana, and today we are going to learn and study about normal distribution. Make sure you prepare your Z-table, pen, and answer sheet for they are essential for this specific lesson. So let's start. In probability theory, a normal distribution is a type of continuous probability distribution for a real-valued random variable.
It is also called Gaussian distribution because it was discovered by Carl Friedrich Gauss. The normal distribution is a continuous probability distribution. It is very important in many fields of science.
Some properties of normal distribution includes a bell curve shape, a total area of 1, symmetrical, and the mean, median, and mode are all equal. Our first topic would be finding the area of the region. It is very important for us to comprehend that all greater than and above values should be subtracted to 1, while all less than and below values should remain the same. Take by way of example, find the area of the region above z is equal to 1.4. You have to locate the equivalent value of 1.4 on your z table. So, 1.4 is equal to 0.9192. You just have to draw a bell-shaped curve or a normal curve. Assume the specific position of 1.4 and shade the above area since we are looking for the above value of 1.4. And since we are looking for the above value of 1.4, 0.9192 should be subtracted to 1. And it is equal to 0.0808. So let's proceed to our activity session. For item number 1, let us find the area of the region less than z is equal to 1.4. So you have to locate the equivalent value of 1.4 on your z table. So 1.4 is equal to 0.9192. So you just have to draw a normal curve, assume the specific position of 1.4, and shade the below area since we are looking for the less than value of 1.4. And since we already comprehend a while ago that all less than and below value should remain the same, the area of the below value of 1.4 is equal to 0.9192. Let's proceed to item number 2. Find the area of the region above z is equal to negative 1.06. Again, you have to locate the equivalent value of negative 1.06 on your z table. So the equivalent value of negative 1.06 is 0.1446. Again, you just have to draw a normal curve, assume the specific position of negative 1.06, and shade the above area since we are looking for the above value of negative 1.06. And since we are looking for the above value of negative 1.06, we should subtract it to 1. So 1 minus negative 1.446 is equal to 0.8554. Let's start the item number 3. Find the area of the region of z is equal to less than 3.01. Again, you have to locate the equivalent value of 3.01 on your z table. So the equivalent value of 3.01 is 0.9987. Draw a normal curve. Assume the specific point of 3.01 and shade the below area since we are looking for the below value of 3.01. And since we already learned a while ago that all less than and below value should remain the same, the below area of 3.01 is equal to 0.9987. Have you already understand our first topic? If you do, let's proceed to our second topic, and it's all about finding z-scores. In finding z-scores, it is important to know the given value, the mean, and the standard deviation. We use this formula. Z is equal to the given value minus mean over standard deviation. Take by way of example, the scores of students for statistics has a mean of 30, a standard deviation of 5, and a corresponding given value of 25. So Z is equal to 25 minus 30 over 5. Z is equal to negative 5 over 5 or negative 1. Since the value of Z is equal to negative 1, we have to locate the equivalent value of negative 1 on your Z table. So negative 1.0 is equal to 0.1587. Go grab your pen and answer sheets, for we are about to start our activity session. In this activity, we have to find the z-score and the area of the following given values. Nothing to worry, because in this case, we have to locate the below values or the below area of the given values, so the value should remain the same. For item number 1, x is equal to 35, mean is equal to 30, and standard deviation is equal to 5. So Z is equal to 35 minus 30 over 5. Z is equal to 5 over 5 or 1. Again, we have to locate the equivalent value of 1 on our Z table. So 1.0 is equal to 0.8413. Again, we just have to draw a normal curve, locate the specific position of 1, and shade the below area since we are looking for the below area of the value 1. Since we are looking for the below value of 1, the area should remain the same, which is 0.8413. Do you get the right answer on item number 1? If you do, let's proceed to item number 2. X is equal to 24. Mean is equal to 23. And the standard deviation is equal to 2. So Z is equal to 24 minus 23 over 2. Z is equal to 1 over 2 or 0.5. Again, you have to locate the equivalent value of 0.5 on our Z table. So 0.5 is equal to 0.6915. Draw a normal curve. Assume the specific position of 0.5. Shade the below area and label it with 0.6915. Let's proceed to item number 3. X is equal to 27, mean is equal to 30, and the standard deviation is equal to 2. So Z is equal to 27 minus 30 over 2. Z is equal to negative 3 over 2 or negative 1.5. Again, you have to locate the equivalent value of negative 1.5 on your Z table. So negative 1.5 is equal to 0.0668. Draw a normal curve. Assume the specific position of negative 1.5. Shade the below area and label it with 0.0668. Did you understand our lesson for today? So what would be the real-life application of this normal distribution? For me, it can be used in measuring the average height of a specific population, in rolling a dice, tossing a coin, testing the IQs of a specific group, or interpreting the average grade or specific subject percentage of a certain class. So that would be all. Thank you for watching.